All right, we've got a short little lesson here where we're going to learn 2 or 3 more theorems to help us prove that lines are parallel, perpendicular, or neither. So let's start with the first one. It doesn't have a name, but it does say if two lines are parallel to the same line, then logically they are parallel to each other. So you can see from our diagram here that if P is parallel to Q and Q is parallel to R, then P is parallel to R. Looks kind of like the law of syllogism, but there is no law of syllogism for parallel lines, so you would have to use this theorem. And if you were going to use this theorem in a proof, as a reason, you could just abbreviate it by saying two lines parallel to the same line. Okay, you don't have to write that whole thing. And you don't want to write theorem 3-7 because as we've talked about, that numbering system only applies to the textbook that we were using at the time. Okay, the next theorem says in a plane, if two lines are perpendicular to the same line, then they are going to be parallel to each other. And if you draw yourself a picture of these, it makes perfect sense. So I've got two lines, M, can't draw very good with my little pen here, M and N. They're both perpendicular to P. Therefore, I know that M and N have to be parallel to each other. So when in doubt, draw yourself a little sketch and you'll be able to easily see what's going on. And then we have the perpendicular transversal theorem, and it says in a plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to that other line. Okay, so if a transversal, so we got J here, J is our transversal, if it's perpendicular to H, which is parallel to K, then I know that that transversal J is also going to be perpendicular to K. Okay, let's see if we can do a little example using maybe one of these proofs. It says in the diagram below, each fence post is parallel to the fence post immediately to the right. So in other words, L1 is parallel to L2, and L2 is parallel to L3, and L3 is parallel to L4. Explain why the fence posts on each end are parallel. So why is L1 parallel to L4? So if I were going to do this as a proof, which I'm not, but that's kind of how I've come to think about things, and hopefully you are too. So let's see what we're given here. Each fence post is parallel to the fence post immediately to the right. So that tells me that L1 fence post is parallel to L2. All right, that's what's given. And L2 is parallel to L3, and L3 is parallel to L4. So those are kind of my givens if we were doing a proof. Those are my givens right there. Okay, so what did I just learn in the theorem? Well, I learned, so look at this, L2 is parallel Sorry about that. Someone stopped at my door. So I've got this line L2 that is parallel to both L1 and L3. So by the theorem above, if a line is parallel, let's go back up here and look at it. If two lines are parallel to the same line, so I've got L1 and L3 that are parallel to the same line, then they're parallel to each other. Not the law of syllogism, but the theorem that says two lines are parallel to the same line. So because of that, I know that L1 is parallel to L3. And then if I take these two together, I can see that L1 and L4 are both parallel to L3. So by that same theorem, they would have to be parallel to each other. So I'm going to say L1 is parallel to L4. And if I were writing a proof, remember my reason would be two lines parallel to the same line. Alrighty. Ooh, now, if we look at the next page here, we have a nice proof. And what I did is I came in here in advance and I gave you a lot of hints. Let's see what it is. We got a picture frame. It says you're going to build this frame just like it is over here. It's not actually below because I moved it, it's to the left. You cut pieces of wood such that the measures of angles 1 and angle 4 are 30 degrees, and the measures of angles 2 and 3 are 60 degrees. Prove that the right and left sides of the frame are parallel. So, I can see that I've got some parallel lines and some perpendicular lines in this frame. So what I did here is I gave you a lot of hints. I want you to try to put together this proof with the hints that I've given you. Or hey, if you don't want to look at the hints, just turn this off and get a blank sheet of paper and go to town. But anyway, here are the hints. I ran out of room, so I had to put step number 7 over here, which I don't like, but that's the way it went. So remember, what I'm trying to prove is that the two sides of the frames are parallel. So PS is parallel to QR. So that's what I'm trying to prove. I wrote down my given here, which they told me that the measure of angle 1 equals the measure of angle 4 equals 30, and so forth. So please take a good, honest effort at this proof, and we'll check it when we get back to class next time. Okay, we got another proof. Why don't you pause here and try to do this one with no hints, and then when you get finished, I'll come back and I'll talk you through it. Okay, so we have our given that BA is perpendicular to BC. So right there, we need to say, well, what does that tell me? Oh, well, I know the definition of perpendicular lines says that if two lines are perpendicular, then we got a right angle. Yes, so that's what I'm going to write down as my next step, and hopefully that's the direction I need to go. So for step 2, I said, okay, well, if BA is perpendicular to BC, then I know that angle ABC is a right angle because of the definition of perpendicular lines. All right, and then I kind of got to look and see what is it I'm trying to prove. I'm trying to prove that angles 1 and 2 are complementary. Well, what does that mean? Oh, it means the sum of their measures is 90 degrees. So I feel like I need 90 degrees in here somewhere, so I'm going to go ahead and make this my next step. And you know what? If I don't need that step, remember, I can just come back and erase it, but I feel like I probably do need that. So I put the measure of angle ABC as 90 degrees for my next step. And then what can I do? Well, they've labeled these angles 1 and 2, so I feel like I'm just going to make an angle addition postulate statement. So that's what I do. I say the measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. That's the angle addition postulate. Oh, and now I'm getting somewhere, because what I can do is I can take this 90 degrees and I can substitute it in right here, which gives me statement number 5, which is the measure of angle 1 plus the measure of angle 2 is 90 degrees. And then I have just what I need, is that angle 1 and 2 are complementary, because that's the definition of complementary angles. Two angles whose sum is 90 degrees. All right, let's see what we have next. Error analysis. Shiro. Good old Shiro. He sketched coplanar lines M, N, and R, just like we see there on his paper. He says that this drawing shows that lines M and N are parallel. What other information does he need about line R for this to be true? Well, what do you think? Here's what I think. I think that I also need to know that R is perpendicular to M. If he had shown me that R is perpendicular to both of those, then I could have used the theorem that says if a line is perpendicular to one of two parallel lines, then it's perpendicular to the other. Or in a plane, if two lines are perpendicular to the same line, that's what I need, not the perpendicular transversal theorem. I actually need the one that says in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So I would need this marking right here to be able to know that M is parallel to N. Okay, so what do we got here? A ladder. The following statements describe a ladder. Based only on the statement, make a conclusion about the rungs one side. So, okay, I'm going to label these each one A, B, C, D, E, because what I think I'm going to have to do is probably draw a picture for each one of these. So I'm feeling like I'll probably do one or two, and then I'll probably let you do the rest of them. So let's do picture A here. I like having all this room over here. So here's my ladder. It says the rungs are perpendicular to one side. So each one of these rungs are perpendicular to a side. So, what does that tell me? Well, if two lines are perpendicular to the same line, then they are what? Parallel. That's the theorem. So this tells me that the rungs are parallel. And I know that because they're all perpendicular to the same line. If two lines are perpendicular to the same line, then they are parallel. Okay, let's look at B, and then I'll let you take off and do the rest of these by yourself, because as I always say, I don't want to deprive you of that fun. Here we go. B, it says the rungs are parallel. So I'm going to mark these as parallel. Rungs are parallel, and the top rung is perpendicular to one side. So what does that tell me? If all these rungs are parallel and one of them is perpendicular to a side, then they're all perpendicular to that side, right? And that is the perpendicular transversal theorem. So I'm going to say all the rungs are perpendicular to that side. And that is the perpendicular transversal theorem. Okay, so why don't you stop here and try to figure out the rest of these. You do need to draw yourself a sketch, and you'll probably have to flip back and forth to those three theorems that I gave you on the front page, because you do kind of get those mixed up in your head, parallel, perpendicular to the same line, to two lines, so it's going to take you a little bit to get comfortable with those. That's why I want you to do the rest of these without my help, and then we'll go over them tomorrow if you need us to. All right. Actually, I'll tell you what they are. C, the rungs are perpendicular to the other side. D, the two sides are parallel. And finally, the last case, the rungs are parallel, but perpendicular to only one side. That side that it talked about in the scenario. Okay, so I gave you the answers and I gave you the reasons for A and B. So for these three, you need to write how come we know those. How come we know those things? So you write the reasons here for these. I'm going to be looking for that when I check your paper next time.